Welcome to your first video of Chapter 7. This is an extension of Chapter 6, but all in terms of radian. So instead of degrees, we're going to talk about radians. So starting off, here's a little vocab review on the left. We have our vertex right here. We have an acute angle right here. Doesn't matter which direction, but it's acute because it's less than 90. And then this angle right here obviously is going to be obtuse because it's bigger than 90, less than 180. And our 360 will be that full circle. So just a thing to look at. We also have some visuals right here. We have 30 degrees, 60 degrees, 90 degrees. You can even put a little box right there. 150, 180 is that straight line. And then 270 is here, and then if you keep going, you'll get that full circle of 360. So just good to have that in the back of our head. Next, we're going to talk about what is a radian. So a radian is an angle measure. We, in Chapter 6, talked all about degrees. In Chapter 7, our angles are all going to be measured in radians. Radians is really S divided by R. S is your arc length. I can label that, that's S. And R is your radius. If we divide S by R, we will get our angle measure in radian. So I have that written down here as well, is the ratio of the arc length, which is S, to the radius, which is R. Okay, so everything is the same, but get out of degrees heading into radian. I'll show you what I mean with a couple examples. So the radian measure, theta, is defined by the equation theta equals S divided by R. No matter what the arc length is, divide it by the radius, you will get the measure of that angle. Here it is in symbols. Here it is visually. And here are some examples on the right. We have 1 radian, 2 radian, 3 radian. You can see is really close to 180, but not. So it's something to kind of keep in our mind. 3 radians are close to 180 degrees, but not officially. Here are some key radian measures. Pi fourths, pi halves, which I can even put that 90 degree again to kind of get that conversion for us. Pi, and then 2 pi is a full circle. Really quickly, let's put the degree measure so we have something to reference. This is 360, full circle. Straight line is 180. We have our 90 degree here, and then hopefully you can guess this would be 45 degrees. It kind of builds. Our mindset is now all radian. Let's keep going. Example 1, determine the radian measure. In figure 5a, we have the radius being 6 and the arc length being 15. Therefore, using our lovely formula, that is arc length divided by radius, we will get 15 centimeters over 6 centimeters. Those units will cancel and you will simplify to get 5 over 2 radian. That is our angle measure. Part B, we're going to do the same formula. So theta is going to equal my arc length over the radius. Looking at this one though, our arc length is 0.12 meters. Our radius is 10 centimeters. So we need to convert those. It doesn't matter which one. I'm just going to convert my 0.12 meters to 12 centimeters. Because you do need the same units. Just like up here, the centimeters cancel. Well, you can't cancel meters and centimeters. They need to be the same. So just keep an eye out. This now becomes 12 centimeters over the radius of 10 centimeters. Our units cancel. We're going to simplify 6/5 radian. And that is our angle measure in terms of radian. Now, heading into this last page, we are going to do a lot of conversions. The reason why we're going to do conversions is because all of chapter 6 was in degrees, so we have that as a base. We're going to use that and develop. We're going to use this lovely fact that 90 degrees is 2 pi radian. Everything can be kind of manipulated from that statement to get the rest of our angles. Okay, we know that because 90 degrees is the same as 2 pi. We just noticed that at the beginning. So we can use that. We can use it as the fact that, okay, normally pi halves equals 90. Well, I have pi fourths. How do you get from pi halves to pi fourths? It's a mouthful. Divide by 2. What you do to one side, you do to the other. So pi fourths is now 45 degrees. And we actually knew that from above as well. You can use that idea. You can also use the fact that 180 degrees is pi radian. Okay, that fact is known from above as well when we looked at the picture. So if I'm working here, pi thirds compared to pi, I can even write this out. I'm going to do my conversion. Pi equals 180 degrees. Well, how do I get from pi to pi over 3? Divide by 3. Which gives you pi thirds is 60 degrees. Fabulous place to build from. Again, I'm saying we're building because this is where we're used to. We're used to degrees. Oh, well, this one's nice. Pi, we already know, is 180. 2 pi, you can always reference your pictures again. Right up here, 2 pi is 360. Or use the fact that pi is 180. Double that, you double 180. Hopefully we're seeing this connection now. If you keep going, this is the same as pi plus pi over 2. We know pi. We know pi over 2. So add those together. 180 plus 90, 270. Pi over 6, I'm going to still use the pi equals 180 conversion. How do I get from pi to pi 6? Divide by 6. So we'll get 30 degrees. Again, my picture's right here. I forgot I put that there, sorry. Use these pictures to help you. If you want to put in the degrees, now that you're getting familiar with the idea, go ahead. These conversions are going to be very, very helpful to go into radian. It's the same as degree. It's the same angle. We're just measuring it in a different unit. Not degrees, but in radian. Now, here is the end-all catch-all, the actual conversions. You can, like we did above, kind of build from pi halves equaling 90 and pi equaling 180. But there's also going to be a lovely formula we're going to use. Our formula is from converting degrees to radian. We're welcoming you back to calc. Remember, unit conversions in calc. So because pi equals 180 degrees, we can use the conversion of pi over 180 degrees or 180 degrees over pi. Depending on which direction you're going will depend on which conversion you use. Let me explain what that means. Here I'm starting with degree. I have 150 degrees. So in order to cancel out my degree units, degree has to be in the denominator, telling me I'm going to use this conversion. Again, because the degree, we're starting with degree, that's our numerator. In order to cancel, it has to be in the denominator. So I'm using the first conversion. I multiply straight across, get 150 pi divided by 180 radian. Degrees, that unit is gone. Simplify as always, and here is your final answer. Don't need to memorize, it just makes sense. If you cancel out degree, it needs to be in the bottom. So if I go the other way, example 4, if I'm going now radian to degree. Radian, I have my pi in the numerator. I need to cancel out that pi radian, which shows me that my pi needs to be in the denominator, showing me I'm going to use this conversion because I want to cancel my units. Radian and pi have to go away. Doing so, you're left with just degree. You'll multiply straight across and simplify, leaving this as your final answer in degree, 330 degrees. Oops, sorry. Let's try a couple and then I'll set you free. We're gonna now convert. Oh, look at this, so fun. When we are converting from degree to radian, we're gonna use one of the conversions above. I'll write them both out. We're either gonna use pi divided by 180 degrees, or we're gonna use 180 degrees divided by pi. It depends where you start. If we look at this first example, 30 degrees, I'm gonna multiply it by one of those ratios to now convert to radian. Since I have degree on top, degree needs to go on bottom for me to cancel. With the degree on bottom, it shows that pi needs to be on top, and I'm using the first conversion. Multiply across, you'll get 30 pi equals 180, which will give you pi over 6. Degrees cancel. I want to make that very, very clear. Let's try another random one. I'm going to do 300 degrees. I'm going to multiply by one of those conversions. Because degree is on top, I need to put degree on the bottom. That means I'm using the first conversion. When I multiply across, my degrees will cancel. I'm going to simplify. I would have 300 pi over 180, which is really 5 pi over 3. If you know these, like if you're looking like, oh, I know 90 degrees is pi halves because we've now talked about it a lot, just put it. Don't worry about the conversion. It will work. If you know any of these already, you can just put the answer. If you don't, that's when I recommend show me your conversion, show me that your units cancel, and you'll be left with radian. I'm going to leave you to do the remainder of these. Example 6 is now actually converting the other way. Again, we have two possibilities. Pi over 180 or 180 divided by pi. We need to decide which conversion to use. Looking at the fact that I have a pi in the numerator, 2 pi over 3, when I multiply, I know the pi needs to go in the bottom because I want to cancel. If that's in the bottom, that means I have 180 degrees in the numerator. and my pi's will cancel. Multiply across, you'll get 360 degrees divided by 3, which is 120 degrees. I got the units I wanted, radians canceled out, and I just showed that 2 pi over 3 is really 120 degrees. Let's do this last one, 5 pi over 6. I need to convert it. Pi is in the numerator, so that means pi is going to go in the denominator, having me use the second conversion. When I multiply across, my pi's will cancel. I'm going to be left with 5 times 180 degrees divided by 6, which is 150 degrees. Again, we're all building from our degree knowledge. So please make sure you finish these examples. We'll check them at the beginning of class. This is not optional. This is required. So this is not going to be extra credit. This is credit for the notes. So please complete these using the conversion, showing that you can convert from radian to degree to radian, and then we'll talk about this in class. Welcome to Chapter 7.